Hello, my name is Charlotte Liddon and I am a PhD student in the Department of Geography and Planning at the University of Liverpool. This video will discuss how mega nourishment schemes at the coast can build resilience and how such interventions can be modelled using Delft3D. Large mega-scale nourishments have been proposed as a promising alternative for traditional beach and shore-face nourishments, especially for locations with large structural erosion and sufficient sediment to dredge. This is because standard beach nourishments can have a short lifespan, while mega-nourishment can effectively distribute sand in surrounding areas. These are aerial photos of the Dutch Sand Engine Peninsula in July 2011 on the left and October 2012 on the right. Nourishment restores and widens the recreational beach and promotes habitat creation. Structures behind the beach are protected as long as the added sediment remains. When erosion continues, beach nourishment does not leave hazards on the beach or in the surf zone. This is a big advantage when compared with hard beach stabilisation structures, such as seawalls or groins. Seawalls may protect structures behind the beach, but they almost always cause the beach in front of the wall to become narrower. If erosion breaches the seawall, then debris from the wall will be left on the beach and in the surf. Since beach nourishment only puts sand on the beach, no debris is left when it erodes. It is important to define convenient locations for beach nourishment. The effectiveness of beach nourishment options depends on the location and on the external agents acting in the system. For example, waves, wind and tidal currents can resuspend sediments and transport them far away from the initial beach nourishment location. Optimum solutions can be found which maximise the transport of sediments in the desired location. This can be the location where the nourishment itself happened or nearby areas. Numerical computer models are a useful tool that can help investigating beach nourishment options under a variety of external forcing conditions and under future climate change scenarios. Many numerical models allow the coupled simulation of hydrodynamic and morphodynamic processes. Delft3D is an open-source numerical model which can carry out simulations of flows, sediment transport, waves, water quality, morphological developments and ecology. The model is comprised of several modules including flow for hydrodynamics, mor for morphology and wave for waves. Each of these modules can be linked with another to create a model which can simulate a range of processes in coastal and estuarine environments. The model is multidimensional, 2D or 3D, which calculates non-steady flow and transport phenomena that result from tidal and meteorological forcing on a curvilinear or flexible mesh boundary-fitted grid. The model uses a graphical user interface, or GUI, and can be set up to operate on a Windows or Linux system. The model requires an accurate bathymetry and can be forced at the boundaries using observational or model data. Here we have an example of how Delft3D can be used to simulate a mega-nourishment option at Barrow in northwest England. The mega-nourishment or sand motor is indicated by the arrow, and you can see how this evolves in time. For this simulation, 20 million cubic metres of sediment is deposited. The sediment size is 100 microns, and a morphological factor of 120 is used, so 31 days represents 10 years. Other conditions can also be tested. For example, we could change the grain size or the shape of the mega-nourishment to see which is the more effective configuration. Here Delft3D is used to simulate a mega-nourishment option in Fleetwood, also in northwest England. This uses a similar setup to the mega-nourishment at Barrow. 20 million cubic metres of sediment is deposited at a size of 100 microns. The change in location and boundary conditions, taken from the CS3X model and a local wave buoy, means the sediment may respond differently in Fleetwood compared to Barrow. Delft3D is an open-source numerical model which can be used to simulate tides, waves, sediment transport, and morphological change in coastal and estuarine environments. It is a user-friendly model thanks to its graphical user interface and is applied here to simulate mega nourishment options in northwest England.